So this project is about grid connected PV win based multi-input transformer for bidirectional operation. So this is our main circuit. In this circuit, these two switches act as a bidirectional converter, and these two switches act as a half-bridge inverter which can invert the DC supply into AC. For the multi-input transformer, there are about 3 input. The first one is from PV panel, and the second is from battery, and the third one is from wind. Instead of wind, we are having the transformer for providing AC supply. So after getting this 3 input, it then converted into DC. Finally, this is our half-bridge inverter for converting this DC into AC for giving input AC to this multi-input transformer. So from the transformer secondary side also we are having one half-bridge converter which acts as a rectifier for converting this AC output into a DC, and this is a single phase inverter circuit for again converting this DC signal into AC. This is a final OR load. So for triggering this MOSFET switches, we are having this PIC controller IC. The switching program are fed into this PIC controller for triggering this MOSFET switches. The PIC controller operates on 5V DC. So for providing a 5V DC, we are having a 7805 regulator and one crystal oscillator for maintaining a clock frequency. And this is a buffer IC for improving the current gain value from the PIC controller. And for providing isolation between this main circuit and the programming circuit, we are having this optocoupler. The optocoupler works on 12V DC. This 2 diode bridge rectifier provides power supply to this optocoupler. So for this main circuit switches, we are having this isolation circuit, and from the transformer secondary side also we are having 2 switches. So for triggering these 2 switches, we are having this PIC controller IC combined with this buffer IC, and here we are having the gate driver which also acts as isolation circuit. Is then isolate the main circuit with this programming circuit. For this 4 switches, we are having this 2 gate driver which provides isolation for this 4 switches. So this is our overall circuit. So to check the input across the PV panel, we are connecting a multimeter across this point. So this is our obtained input from the PV panel. So for checking the input across this battery, we are connecting a probe across this point, and this is our obtained input for the PV battery. We are connecting a probe across this point for checking the input AC. This is our obtained input AC. So to check the obtained AC output across this half-bridge inverter, we are connecting a probe across this point, and this is our obtained AC with a high frequency. By zooming this, we can view our obtained AC output. So for measuring our DC output, we are connecting a probe across this point, and this is our obtained DC output. Finally, by connecting a probe across this point, we are measuring our obtained AC output. Finally, by connecting a probe across this point, we are measuring our obtained AC output, and this is our obtained AC output. Now to check the operation, whether it works on PV alone without battery and without wind, we are removing this wind connection and the battery connection, and we are checking our AC output by connecting a probe across this point, and this is our obtained AC output. In the second case, we are checking our entire circuit without PV panel and wind, only with the battery supply. And through this point we are checking our AC output, and this is our obtained AC output. Okay. Now instead of PV and battery, we are checking the kit with this wind supply. And this is our obtained AC output. To check the bidirectional condition, we are removing this all these three input, and we are giving supply through this load. Through the AC transformer, we are giving supply on the output side to check whether this kit works on bidirectional condition, and on the input side we are checking whether it gets charging. And this is our obtained output. So this indicates that the kit works on even bidirectional condition too.